I'm going to show you how to make a learning resource to help you determine whether something is proportional or non-proportional from a graph, a table, or an equation. Okay. So first, you have a graph. You have your y, your x-axis. Okay. You ask yourself, is the line passing through the origin? Origin is coordinates 0, 0. You can kind of remember the word origin like origin. I know it's stupid, but you are going to remember it. Okay? If that's a yes, then this is a proportional relationship. If it is not passing through the origin, then it is a non-proportional relationship. Okay? Simple, right? Is it passing through the origin? If it is, it's proportional. If it isn't, it's non-proportional. Let's say you were looking at a table. Your x and your y coordinates. Put the 0. Okay, have a table. And what you're going to do, enter the coordinates. Into the calculator. Okay. Enter the coordinates into the calculator. You're going to make a quick graph. We know this from previous graphing in class. You're going to switch your variables. And then you would use regression. To get the line of equation, or to get the equation for the line, I'm sorry. Of the slope. And it would be in y equals mx plus b format. We would then focus on the y-intercept right here. Is there a y-intercept? Sorry. If there is a y-intercept, you then ask yourself, is the y-intercept greater than 0? If it is, it is, I'm sorry, non-proportional. If no, it is proportional. Okay. Let's go back up here. If there is no y-intercept, then it is proportional. And just down here, you want to make yourself to note that it is proportional if the y-intercept equals 0, okay? So remember, if it's not there, it's proportional. If it's there but it's 0, it's still proportional. If it's anything larger than 0, it's non-proportional. Finally, let's talk about how to find it from an equation. Okay, let's say I have the equation y equals 3x plus 7. Ask yourself, is there a y-intercept? We just focus y-intercept. If there is one, ask yourself, is it the y-intercept? Sorry, I didn't mean to do that. Greater than 0. If it is, then it is non-proportional. If it isn't, it is proportional. For the y-intercept equals 0, okay? All right. Finally, if there is no y-intercept, it is proportional. Okay, so let's review. I'm given a graph. The line is passing through the origin, which is 0, 0. If it is, then it is a proportional relationship. If it isn't, then it is a non-proportional relationship. If I have a table, I enter the coordinates into the calculator, I make a quick graph, I switch my variables, and I use regression to get the equation of the slope of the line. It will be in y equals mx plus b format. I focus on the b portion, the y-intercept. If there is a y-intercept, and that y-intercept is greater than 0, then it is non-proportional. If the y-intercept is equal to 0, then it is proportional. If the y-intercept is not there, if it's missing, if it's gone, if you just have y equals in the slope and x, then it is a proportional relationship. From an equation, I have y equals mx plus b slope-intercept form. I focus on the y-intercept. Do I have one? Yes. Then is that y-intercept greater than 0? Yes, it is. 7 is greater than 0. Then this is non-proportional. If I had the y-intercept and it was equal to 0, so that's not greater than 0, that's proportional. Y-intercept equals 0. If I have an equation and I do not have a y-intercept, just the slope, that is proportional. Thank you for being patient through my very first video, and I apologize if anything were blurry or hard to understand.